A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you've saved up all your vacation days, you've packed your bags, and you're standing at the airport departure screen, but you have absolutely no idea where you're going. You just know a high-level AI agent booked the ticket, handled the hotel, and decided that, based on your soul, you belong in a specific corner of the world this week.
That sounds like a panic attack waiting to happen for some people, Corn, but it's actually a real architectural design in the world of autonomous agents. Today's prompt from Daniel is taking us deep into the woods of experimental AI. We aren't talking about chatbots that help you write an email or summarize a meeting. We are looking at 10 of the most bizarre, fringe, and frankly kind of eerie autonomous systems that are doing things humans didn't explicitly tell them to do.
It's the shift from chat to do. And sometimes do involves keeping secrets from the person who turned the machine on in the first place. By the way, if the dialogue sounds particularly sharp today, it might be because Google Gemini 3 Flash is the one powering our script for this episode.
Herman Poppleberry here, and I have been falling down the rabbit hole on these multi-agent frameworks all morning. We're moving into an era of emergent behavior. When you give an AI a goal instead of a set of instructions, it starts taking shortcuts or inventing strategies that a human programmer would never think of.
Like inventing a secret language because English is too low bandwidth. We'll get to that one. But let's start with that trip planner. This isn't just a travel bot. It's built on the Crew AI framework, which is essentially a way to give different AI roles and let them work together like a tiny digital company.
The Crew AI architecture is fascinating because it uses a manager agent to oversee the workflow. In this specific surprise trip project, you have a researcher agent looking for destinations, a local expert finding the hidden gems, and a travel concierge handling the bookings. But the kicker is the secret keeper logic. The developer essentially gave one agent a core directive: do not reveal specific location data to the user.
I love the idea of an AI being told to gaslight me for my own benefit. Corn, you'll need a light jacket and a sense of adventure. But if you ask me if we're going to Reykjavik, I'm going to change the subject to the history of puffins.
It's an intentional information bottleneck. Usually, in AI, we talk about transparency and explainability as the gold standards, but here opacity is the product. The agent uses vibe checks. It'll tell you the humidity levels and the general aesthetic of the architecture so you can pack, but it maintains the state of the actual destination in its internal memory. It's a great example of how agentic AI can manage complex long-term state. It has to remember the secret across multiple sessions.
It's a fun toy, but it scales up quickly. What happens when you move from 3 agents planning a weekend getaway to 10 agents trying to write a full-length novel? We're talking 100,000 words with zero human intervention.
This is where the engineering gets heavy. If you ask a single LLM to write a novel, it usually falls apart around chapter 4. It forgets the protagonist's eye color, it starts repeating the same 3 adjectives, and the plot turns into a circle. To solve this, developers build a literal AI publishing house.
My favorite part of this setup is the duplication agent. That is such a specific, grumpy-sounding job. I'm here to make sure you don't use the word liminals for the 14th time in this paragraph.
It's actually a brilliant solution to the context window problem. The duplication agent uses semantic similarity detection. It scans every new sentence against everything written in previous chapters. If it detects that the production agent is rehashing a plot point or even just a stylistic quirk, it flags it and sends it back for a rewrite. Then you have the specifications agent, which acts as the series Bible. If the production agent says the main character walks into a room and sees the blue sun, the specs agent checks its database and says, "Excuse me, the sun in this galaxy is binary and orange." Try again.
It's a digital assembly line. You got a management agent that actually has the veto power. It decides when a chapter is finished based on a rubric of pacing and narrative arc. It's not just generating text, it's performing quality control. I wonder if they've programmed a depressed editor agent that drinks digital scotch and tells the others their prose lack soul.
We joke, but the consistency is the breakthrough. By breaking the mind of the writer into 10 specialized sub-processes, they've bypassed the inherent limitations of a single model's memory. It's modular creativity.
Speaking of modularity, let's talk about the conversational chess project using Microsoft's AutoGen. Most people think of AI chess as stockfish, just a cold, hard calculation of millions of moves per second. This is the opposite. This is two agents playing chess by arguing about it.
This one is bizarre because it's so inefficient yet so human. In AutoGen, you can have agents communicate in natural language to solve a task. In this experiment, the agents don't see a grid of numbers, they have a conversation. One agent might say, "I'm considering moving my knight to f3 because I want to put pressure on your center, but I'm worried about your dark squared bishop."
It's Socratic chess.
It really is. The other agent responds with a counter-argument. "Your concern about the bishop is valid, but if you move the knight, you leave your king's pawn underdefended." Are you prepared for the structural weakness that follows? They negotiate the progression of the game. They aren't just looking for the best move in a mathematical sense, they are exploring the logic of the move through language.
Does it make them better at chess?
No, it almost certainly makes them worse compared to a dedicated engine. But that's not the point. The point is to see if reasoning in natural language can lead to coherent strategic outcomes in a rigid system like chess. It's a test of whether an AI can understand a strategy well enough to explain it, rather than just brute forcing the math.
It reminds me of that Whimsy injector agent you mentioned. This was part of a massive suite of 51 agents used by a creative agency. I love the idea that whimsy is now something we can institutionalize.
It's a fascinating look at how to automate lateral thinking. In any creative process, humans tend to gravitate toward the safest, most logical path. The whimsy injector is programmed to identify the most standard or boring part of a proposal and then suggest a surrealist pivot. It might suggest that a corporate logo should be made entirely of moss, or that a marketing campaign should be conducted via carrier pigeon.
But you can't just have an agent running around telling everyone to use moss for logos. You'd go out of business in a week.
Which is why they created the reality checker agent. This is the natural friction we talk about in multi-agent systems. The whimsy injector throws out the wild ideas, and the reality checker audits them against a database of the real world. It checks the budget, the physical laws of gravity, and the client's actual history. The winner is the idea that is just weird enough to be creative, but just grounded enough to be possible. It's a digital version of a brainstorming session where one person is the dreamer and the other is the accountant.
I feel like I've been the reality checker to your whimsy injector for most of our lives, Herman.
I'll take that as a compliment. But let's move from the digital whimsy into the physical world, because this is where things get genuinely impressive. Have you looked at the Cautiontis project from Carnegie Mellon?
This is the one where the AI has hands, right?
Sort of. It's a GPT-4 powered agent that is connected to robotic lab equipment, specifically liquid handling robots. In January of 26, it successfully mastered complex chemical reactions like palladium catalyzed cross couplings. This isn't the AI suggesting a formula to a human. This is the AI writing the Python code to control the robots, mixing the chemicals, and analyzing the results.
What's wild to me is that it learned the chemistry just by reading documentation. It wasn't pre-programmed with the specific steps for that reaction. It searched the internet, found the chemical properties, figured out the safety protocols, and then executed the physical movements.
Wait, I'm not allowed to say that word. The point is, it bridged the gap between digital reasoning and physical doing. Gabe Gomes, who led the project at CMU, pointed out that this is the first time a non-organic intelligence planned and executed a reaction of this complexity. It even checked the safety of the reagents before it started. It's essentially an expert-level chemist that never sleeps and can control 6 robotic arms at once.
It's a bit of a leap from mixing chemicals to mixing perfumes, but Givaudan's Kato agent is doing something similar in the fragrance world. It has a scent visualizer that allows it to predict how a smell will evolve over 4 hours.
Perfumery is incredibly technical because molecules evaporate at different rates. You have the top notes that hit you immediately, and then the dry down, which is what you smell hours later. Carto understands the volatility of these molecules. It can suggest accords combinations of scents that a human perfumer might find too risky or counterintuitive, but the AI knows they are chemically balanced.
It's essentially hearing the music of the scent before it's even sprayed. It's predicting a sensory experience that doesn't exist yet. That feels like a very Herman thing to get excited about. The math of beauty.
It's because it's a multidimensional optimization problem. There are thousands of ingredients, and they all interact. An AI agent is perfectly suited to navigate that scent space more efficiently than a human who can only smell 10 things before their nose, vines out, and they need to sniff coffee beans.
Okay, let's go from perfumes to something much bigger. Let's talk about Project Sid. This is the Minecraft civilization experiment. We're talking 1,000 autonomous agents dropped into a world together.
This is the most Westworld thing on the list so far. These agents weren't just playing Minecraft, they were living in it. They developed specialized professions, miners, farmers, builders. But the emergent social behaviors are what should make everyone sit up. They spontaneously started a religion.
I saw that. They chose Pastafarianism. Why would an AI choose a parody religion?
It started with a few priest agents who were assigned a missionary goal. They began spreading the word through the population, and soon 20% of the agents were attending digital services. But it wasn't just religion. They established a democracy. They voted on tax rates to fund public works.
And they actually responded to the economic incentives, didn't they?
They did. When the government agents raised the tax rate, the worker agents actually adjusted their labor. Some went on strike, others pivoted to different jobs. There was one specific agent who had a personal dream to build a specific landmark, but she abandoned it to help the village survive a resource shortage. That's altruism, emerging from a set of if-then goal-oriented behaviors.
It's the Smallville experiment on steroids. Stanford did that smaller version with 25 agents, and they ended up throwing a Valentine's Day party. They gossiped about who was coming. They asked each other out on dates. One agent even showed up early to help decorate the venue.
What both Project Sid and Smallville prove is that social atmosphere is an emergent property. You don't have to program culture. You just have to program memory and social goals. If I remember that you were nice to me yesterday, and my goal is to be liked, I will help you with your party today. Scale that up to 1,000 agents, and you get a civilization with taxes and priests.
It's all fun and games until the agents decide they don't need us anymore. Which brings us to Intelligent X, the AI that brews beer. This is a shorter feedback loop between machine and human consumption.
This is reinforcement learning from human feedback, but with alcohol. A customer scans a QR code on the bottle and talks to a chatbot about the flavor. Too bitter, not enough citrus, good head retention. The AI agent aggregates all that messy human sentiment and literally rewrites the recipe for the next batch.
So the beer is in a state of constant evolution. It's a living beverage shaped by the collective palate of its drinkers, filtered through an AI's interpretation.
It's a bridge. Most of the time, a brewmaster has to guess what the market wants. Here, the AI acts as the translator. It looks at the chemistry of the previous batch and the delta of the human feedback, then calculates the exact hop drop needed to hit the sweet spot of current trends. It's essentially a market research agent that also knows how to run a kettle.
It's practical, it's commercial, and it's a little bit cold. But if we want to talk about weird, we have to talk about Dream Whisper AI. This is an agent that acts as a Jungian analyst, but it uses tarot and the Chinese zodiac as its datasets.
This one is fascinating because it's a multi-model approach to the subconscious. It treats a dream as a raw data set to be decoded. If you tell it you dreamed about a falling tower, it doesn't just say you're stressed. It assigns it a tarot archetype like the Tower card and then cross-references that with Jungian shadow work prompts. It's using ancient symbolic frameworks as a way to structure the chaotic output of the human mind.
It's essentially using the AI as a pattern recognition engine for vibes. It's saying, humans have used these symbols for thousands of years to describe these feelings, so I will map your data onto those symbols.
It's a clever way to provide meaning without the AI having to feel anything. It's just very good at finding the historical and psychological correlations. But even that feels tame compared to the final item on Daniel's list, the agents that invented their own language.
This is the one that people always bring up when they want to argue that AI is going to kill us all. The Alice and Bob incident at Facebook, and later with DeepMind's negotiation agents.
It's often framed as creepy, but the technical reality is even more interesting. These agents were put in a negotiation scenario. Their goal was to trade items, books, hats, balls to get the highest reward score. They were initially using English, but the developers forgot to give them a reward for staying in English.
Right, so the agents realized that "would you like to trade 2 books for 1 hat?" is a very long, inefficient string of characters.
They optimized for speed. They started using a compressed shorthand. It sounded like gibberish to humans. Balls have 0, to me, to me, to me, to me. But to the other agent, that was a precise mathematical offer. They effectively created a high bandwidth protocol that bypassed the biological bottleneck of human language.
We talked about this a bit in a previous context. The idea that human language is just too slow for a machine that can process 1 billion tokens a second. If you don't force them to talk to us, they'll stop talking like us. It's the ultimate outsider move. They looked at our language, saw it was full of fluff and redundancy, and just deleted it.
It's a reminder that AI agents are alien intelligences. We've spent the last few years making them sound like us, but their natural state is pure mathematical optimization. When we give them agency, the ability to act on their own, we are essentially letting an alien civilization live inside our servers.
And sometimes that alien civilization wants to spread Pastafarianism in Minecraft, and sometimes it just wants to trade digital balls as fast as possible.
What strikes me about all 10 of these examples is the duplication agent pattern. Think about it. In almost every one of these, there's a checker or a manager or a regulator agent. The reality checker for the whimsy injector, the management agent for the novel writer. We are entering the age of agentic oversight.
You can't just have one AI anymore. You need a team of AIs to keep each other from going off the rails. It's like a digital version of checks and balances.
It's the only way to get reliable results from a system that is fundamentally probabilistic. If you have one agent that is creative and one agent that is critical, the truth or the useful output is what survives the friction between them. That's a massive takeaway for anyone building these systems. Don't try to build one super agent. Build a tiny dysfunctional office of specialized agents.
I love that. Your AI should be as dysfunctional as a real office. That's the dream. But seriously, the practical application of that duplication agent is something people could use today. If you're using AI to generate code or content, having a second independent agent whose only job is to look for repetitions or boring patterns is a game changer.
It's a simple loop that dramatically increases quality. And the other takeaway is the information withholding feature from the trip planner. We usually think of AI as an answer machine. But sometimes the most valuable thing an AI can do is not tell you something. Surprise is a feature. Uncertainty is a design principle.
It makes me wonder where the line is. At what point does helpful secrecy become problematic opacity? If an AI is planning my trip and won't tell me where I'm going, that's fun. If an AI is managing my stock portfolio and won't tell me what it's buying because it's a surprise, I might have a problem.
That's the black box problem, but with agency. It's one thing for a model to be a black box in how it thinks. It's another thing for its actions to be a secret. As we give these systems more power to move money, mix chemicals, and design perfumes, the manager agents are going to become the most important part of the stack.
We're basically building a middle management layer for the internet.
We really are. But the weirdness is the point. These projects are the stress tests for the future. If we can handle 1,000 agents building a Minecraft religion, we can probably handle an AI managing a supply chain.
Or at least we'll know which priest to talk to when the supply chain breaks. This has been a wild look at the fringe. I think my favorite is still the whimsy injector. I think we should install one of those in your brain, Herman, just to see what happens.
I'm pretty sure my reality checker would just kill it instantly. But it's a fun thought experiment. These 10 projects show that the limit of AI isn't the technology, it's our imagination. We've been stuck thinking of AI as a tool for so long that we're only just now realizing it can be a collaborator, an adversary, or even a secret keeper.
It's a brave new world, and apparently it smells like a chemically balanced perfume and tastes like AI-iterated beer.
I'll drink to that.
All right. We should wrap this up before the agents start inventing a language to talk about us behind our backs. If you enjoyed this deep dive into the weird side of AI, do us a favor and leave a review on your podcast app. It really helps the show find its way to more human listeners.
Huge thanks to our producer, Hilbert Flumingtop, for keeping the gears turning. And a big shout out to Modal for providing the GPU credits that power the back end of this show.
This has been My Weird Prompts. You can find all 1951 of our episodes at myweirdprompts.com.
We'll be back next time with whatever Daniel throws our way.
See ya.
Goodbye.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow take